Okay, hi everyone. Thanks because join us today's webinar. Okay, today's webinar is Salford Predictive Modeler, how to build regression models. I'm Nur Sulawati. Currently, I'm technical support, especially at Visit System. Visit System are independent local representation for Minitab product and training for Malaysia, Singapore, and Batam, Indonesia. Salford Predictive is a separated software, okay, from our flagship product, Minitab Statistical software, but it's one of the Minitab product. Okay, before we get started, there are a few housekeeping items to take note. If you have a question during presentation, please type them into the question box in your control panel. You may send in any time throughout the presentation, but I will address them during Q&A session at the end of webinar. Kindly ensure that you have connected to the audio via computer speaker. Okay, please fill up our survey before you exit the tab. This survey will help us to improve the quality of our upcoming webinar. For your information, this webinar will be recorded and therefore it will be set as listen only mode to avoid interruption to the audio recording. The recording will be accessible anytime later on our website www.visits.com or by subscribing to our YouTube channel Minitab Malaysia and Singapore. Okay, so today's agenda is now most of us talk about big data. One of the area in the big data is a machine learning. Okay, for us in Minitab, we have another product we call Salford Predictive Modeler as a machine learning software. Okay, the major analysis for Salford Predictive Modeler, SPM, is a decision tree model. One of the main is we call it classification and regression tree, or we call it CUT. And then today is we focus on regression questions only. And then every software has their own features. For SPM, we call it automate, where we do the experimental or some tuning parameter for all model before we choose the best model to do the prediction. Okay, so we go for machine learning. Okay, machine learning is a subset of artificial intelligence. So maybe machine learning can define as modern statistics plus with the computer sciences. Okay, basically machine learning is algorithm use computation method to learn information directly from the data without relying on the predictive equation to the model and then make sure to do the prediction and decision. So means that machine learning is learn from the data, historical data, and forward to do the prediction and the decisions. Okay, so the main concept of the machine learning is a splitting data into the training set and the test set. Okay, training set or sometimes we call it learn data set is used to create the models, and then the test set is used to assess the model performance. Okay, typically for Salford Predictive, the default setting, we split our data to 80 training and 20 testing. Okay, and then another splitting of the data, we have a cross validation is for K fault cross validation. Okay, cross validation means that you split the data into the K subset of full. Okay, fit the models using the full at set 1, compute the error using the help all or test full. Repeat the K times holding out each of 1, select the model using the summary statistic based on the test error. So easy way is, let's say you have a 100 data set, you divide by 10 group, means that K equal to 10 right now. So this one is a K. So every K, you have a 10 inside there, 10 data set. So means that you manipulate K1 until K9 be the training data set, means that you build the data set, and then this one is K10, you assign as a test data set. This one is the first iteration. The second part, maybe you choose K1 until to the K8, and then K10, and then K9 can be other testing data set. So you sum all together, and then you can get the summary statistic based on that average of the K. Means that all the K, actually you do the testing data set and then the training data set. So this one is a cross validation part. For the splitting data set, maybe you have 100 data set. So 80% means that 80 data set be the training set, and then 20 set data set can be the testing data set. So this one is the splitting the data set for machine learning. Okay, basically, machine learning can be two categories: is supervised and unsupervised. Okay, machine learning unsupervised means that you have no target, but you want to group in your data. So, for example, we go for the clustering, or we can go for the multivariate analysis, let's say principal component analysis, factor analysis. So this one is, we call it the unsupervised. Another category is, we call it supervised, means that when you have a target, your Y, and then you have multiple predictor. Inside the supervised, we have a classification, we have regression. Okay, classification is, let's say your Y now is something like reject, accept, yes, no, is a categorical, or you have let's say multi-classification. Let's say you have a low, medium, and high. So means that is we consider that classification. So in generally mean that, let's say your data is a test data set, yes or no, is a binomial. And then the other cases, we call it the regression, means that your Y right now, your output is a numeric data, whether it's a measurement, let's say length, temperature, or your weight. So this one is, we consider that the regression cases. Regression here is not the referred to the traditional method, is we call it regression. Regression here just is name for the categorical of a supervised. Okay, so regression refer to numeric data set. Your Y is a numeric, and then if let's say your Y is a classification, so you go for the classification. Okay, so but today we just focus on the regression part. Okay. So regression means that the value of quantitative variables are number that usually represent a count or measurement. So sometimes we call it numeric is quantitative. Sometimes we call it the continuous. Something like number as long as a decimal point, or without decimal point, we consider that is a regression cases. For example, is a number of customer complaint, proportion of the customer eligible for a rebate, or fill weight of a cereal box. Okay, so maybe the price of the house. Okay, so something like the number. So we consider that is one is the regression category. Okay, for the supervised. Okay, so we go for Salford Predictive Modeler, or SPM. Okay, so Salford Predictive Modeler is a machine learning software founded in 1983, but 2017 Minitab accurate Salford system. SPM is a reliable and robust software because it was created by inventor of predictive analytics and machine learning. They are Dr. Jerome Friedman, okay? They are Leo Breiman, They are Richard Awesome, they are Charles Stone, and then the other west one is Dr. Dan Steinberg. So SPN are machine learning software and data driven to improve the decision making. Okay, so in SPM, known as easy of use, something like Minitab statistical software, because no need to coding to get the model. It's just like Minitab. You just click, or we call it GUI software to do the modeling. Okay, I think I go to directly to the Salford first before we go further. So once you launch the Salford Predictive Modeler, now is a version 8.3. So you can see that we have a classic output. We have a two pane, okay? We have a left for the report content and then the right for the text editor. So it's something like different in the Minitab statistical software. We have the output pane, we have the data set, but if you go for the Salford Predictive, we have a classic output here. And then the same thing, we have a menu button here. We have file, we have edit menu, we have a view, we have explore, we have model here, we have the report and the window and help. Okay, something like the same thing. And then we have icon like say is open the data set. So this one is the interface of the Salford Predictive Modeler. Okay, so I go to back to this one. Okay. Okay, basically, SPN can implement in various of industry. For example, manufacturing. So maybe you want to know about the defect, okay, or you want to do the preventive maintenance, or maybe you are from the finance services. Maybe you want to do the loan default, predictive or loan default. Or you are coming from the healthcare, maybe you want to do the disease or prevention, or like something like you want to improve the waiting time for hospital. Okay, let's say for emergency room before treatment, get the treatment. So you want to do the prediction on that time. So you can using the SPM or others industry. Let's say you want to do insurance claims, or let's say you are from the sales department, maybe you want to go do the cross sell or upsell, okay, or you are from the marketing, you can go for the customer segmentation using the SPM. Okay, so this one is some organization already using SPM. Okay, for example, it's Bank of America, if Atate and Light, these are from the US. Okay, but if let's say you want to see more application, or I will suggest that to you, visit our website www.minitab.com, and then you choose the case study to see how SPN help our customer to solve their problem. Okay, so this one is I go through basically in this PowerPoint first before I go further into the SPM. Okay, basically SPM works like you need to bring the data, this meaning that you need to import the data, but in SPM they not only can read the Excel or Minitab, we have others type of the data they can read. Okay, if let's say you want to import the data, and then after you import the data, they have a lot something like descriptive, okay, or we call it the stat. This meaning that you can get for the summary statistic, let's say mean, mode, quartile, something that the one is squishness, and then you have a graph that let's say histogram, bar chart, pie chart, and then the main important here they have a correlation. Okay, not the only Pearson or Spearman, but there are a lot of type of a correlation they can provide for you. Okay, after you do the something like restrictive statistic and know the correlation for each variables, so they can create the predictive modeler. So in SPM, they have an algorithm like CAR, is classification and regression tree, and then they have advanced, we call it advanced model. let's say it's a tree-net model, it's a random forest, or you are coming from the regression modeler. So maybe you want to have the same thing, is an equation. So you can go for the MARS, multiple adaptive regression spline. Or we have advanced, like say, rule learner, isolate, GPS, general purpose model. So every thing about the model algorithm inside there, we call it is analysis engine. And then after you get the best model, okay, after that you get model whether it's a cut, whether it's a trained or random forest, you can deploy the model to do the prediction, or maybe you want to do the translated to others language, let's say for the C language or PMML or others language. Okay, so this one is how SPM work. So first thing, you need to import the data first, and then you do the descriptive statistic, and then you create the model, build the model. After that, you do the prediction. Okay. So this one is for principal modeling engine. We have for, I just focus for today, but I think if let's say I have more time, I can go one by one. But more here is I go for the basic one, is a cut. Cut basically is a Bryman, Olsen, and the Stone. The cut is a decision tree algorithm that works by creating a set of yes or rows that splitting the response target into the partition based on the predictor setting. So cut meaning that you have a tree, which is you have a yes or no, smaller or bigger. Okay, it's a splitting part. And then we have another one is we call it random forest. Random forest is by Lear Bryman and then other. This one is a collection of a mini cut, meaning that you have a cut here in collection of mini cut that are not influenced by each other when constructed, but normally random forest is suitable for the handles wide data set, means that you have a lot of variables rather than number of data set. Okay, for the random forest, but it's just one is a suggestion. Okay, and then we have another modeling, which is we call it MARS. Okay, multiple adaptive spline regression. Regression spline, sorry. Model is a piece together a series of straight line which each allowed in own slope. Okay, so this model is ideal for the who prefer result in a form similar to traditional regression while capture nullity and interaction. Basically, like something like we have a combination of the straight line. Okay, you plus all the straight line, and then you can create the Mars. It's a simple thing, okay? Can I describe to you? Okay, and because for the regression part, we have the linear regression, straight line. So meaning that if let's say you have a quadratic, something like quadratic, okay, something like quadratic. So meaning that you need have some like first linear, okay, straight line, second straight line, third straight line, and then you combine all together. So this one is called Mars. Okay, and then we have another advanced model. Okay, so the basic starting for the cut also is we call it TreeNet. TreeNet is a by German firm. Okay, it's a gradient boosting algorithm that sequential fit smallest cut tree and then use the error from the previous tree to create a new prediction and update the models. Okay, this one is a more flexible and powerful machine learning tools. Okay, but almost for the random forest and TreeNet is coming from the cut first. Okay, so that's why for today we focus on the cut. Okay, classification and regression tree. Okay, so as I say that cut is a decision tree algorithm that works by creating a set of yes or no rules that split the response or our target variable into the partition based on the predictor setting. Okay, and then this one is a prediction is produced for each partition. I think the best thing we go through the cut. We know about the cut, we go for the some terminology of the cut. So meaning that now cut is a tree. So this one is we call it tree. It's a splitting by no and yes. Okay, means that is smaller. This one is the bigger one. Okay, so this one is, we call it CAT. Okay, classification and regression tree. Okay, some terminology in the CAT is we call it the first node here. We call it root node. Okay, it's the top of node. Okay, so we call it, this one is a root node. And then the nodes are building the blocks. So for this one, we have a 5 nodes. Okay, 5 nodes. And then the split value here, so this one is a predictor. Okay, predictor. This one is a value, is less than or equal to 21. So this one is, we call it a tree split. When a variable is partitioned, this tree has a 2 splitting, whether age less than 21 or another splitting is a semen amount is equal, less than or equal to 355. So this one is a split. Okay, splitter. And then the third terminal is, we call it terminal node, which is a node that has no sub-branch, so no partition. So this one is, we call it terminal node. For the SPM, if let's say you see the red color here, okay, so red color box, so meaning that this one is the terminal node. So inside the terminal node, they have the predictive value. Okay, predictive value. The predictive value is in a CAT regression model is the average of the target variable for record that fall in the terminal nodes. Okay, so meaning that, let's say you want to have average here, so means that this one is the predictive. Predictive is coming from each day more than 21 and semen amount is less than 355. So meaning that the prediction is can be 37.063. Okay. So meaning that now for the terminology, we have a root node splitting value. Splitting is coming from predictive setting. Okay, predictive. And then we have a terminal node, means that no sub branch. And then inside the terminal node, we have the predictive value. Okay, so this one is, we call it CAT. Okay, so basically CAT used to identify the most important predictor of a response or the target. So we want to discover combination of predictor or response, and then you can visualize your finding because now we have a tree. Okay, and then maybe you can create the business rules that are easy to understand, use and apply to your process in the real time. So the advantage of CAT we consider that it's non-parametric. Okay, because CAT is not rely on any assumption, okay, or any distribution. Okay, so CAT is not significant impact by outliers in the output. CAT can handle the missing data. CAT can handle the outliers, meaning that we have a surrogate. Okay, we need they merge together. Okay, what is the similarity? Okay, and then that's why CAT can handle the outliers and missing data. CAT maybe is sophisticated method for dealing the missing variables. Okay, CAT is relatively simple for non-statistician to interpret. Okay, because CAT have the tree. Okay, regression we have the equation, but the CAT we have a tree. Okay, so I have one case study here. Okay, so manufacturer of smart water meter investigate what caused bias in users reading. They also want to do the prediction of the bias in the users reading. So this one is the example of the predictor, and then they have a users bias, meaning that they have a numeric data here. Okay, all this one is the predictor. They have a 40 predictor. So I think I go directly to the Salford first. Okay. So this one is an interface for the Salford Predictive Modeler. So for the SPM, we need to import data set into this Salford Predictive. You cannot type in one by one. You need to import. Okay, so how? Go to file, import data, okay, or Z to go for open data set. Okay, so for the data set, this one is the type of the data set as SPN can read it for you. Okay, whether it's access file or maybe you have HTML, JMP, okay, or maybe of course for the Minitab they can read for you. Okay, Stata or SPSS. Okay, so this one. So but today I go for the water meter, so I just include with the Minitab worksheet and then open. Okay, I go back, go to open that set. You choose water meter, click open. So once you call the data set, they pop up the activity windows. We call it, this one is activity. Okay, in the activity windows, they provide the variables, they provide the data set, meaning that have how many records you have, how many data set you have. Okay, and then how many variables they have. Okay, how many variable they have, what type of the variable they have. Let's say it's character, means that is a text data set. So they have one character. Numeric is this meaning that your data set in the numeric data. Okay, so they consider that it's a numeric. So they provide this kind of the information. Okay, maybe you have a alternative whether you want to do the alphabet or file order. Okay, and then in the activity window, basically you can view your data set before you go further. So just put in the activity, view data set. So meaning that now this one is your data set. So maybe you want to checking whether it's a variable, is it okay or not. Okay, okay. So you can go further one by one. Okay, so I go back to the activity windows. Okay, in the activity window also they provide the stat menu button. Okay, whether which one is for descriptive statistic. Okay, they provide also for graph correlation, data preparation. I not go through for the data preparation today. And then go, the main purpose here, you want to build the model. But I go one by one. So for the stat data set, maybe you want to include all the data set here, all the variables. Okay, or you can select one by one if let's say you just only interest on that variable only. So click all and then click OK. Okay, so now they provide the descriptive statistic, whether it's a simple one or you want to go for the further one. So you just click brief or full. Okay, I go back to this one activity, you choose the step and then you choose all this one and then you click OK. So you get this kind of the result. So you can see that the missing data, the skewness, the standard deviation for each variables. Okay. And then I go back to the activity windows again. I go for the graph. Okay, so basically I just want to the users bias only. Okay, I click here, generate chart. Okay, so they provide the histogram. So in this windows, you can change it to others one, maybe you dot or plot or line or profile. Okay, something you can manipulate this one. Is edit your data. Maybe you want not enough with the number of buying, so you want to increase or decrease. Okay, so you can see that this one for the frequency data set. I go back to the activity windows, go for the correlation. It's the one is interesting part because we want to do the modeling because we want to know about the variables correlate relation between each variables, between variables and the output. Okay, yeah, or y. So click here. So same thing. So you select all. So you see, you can see here for the Pearson, maybe basic we always using the Pearson product moment, but in SPN they provide more than that. So maybe you're familiar with the sum of cross product, covariance, skewness, maybe variance, Spearman rank order. Because for information in Minitab statistical software, we provide the Pearson product moment and the Spearman rank order. So if let's say you want more advanced, so you need go for the SPM. Okay, so this one, we choose only Pearson. Okay, I'm familiar with the Pearson moment product. Okay, so click OK. they generate the output to you. Okay, in SPM they have a color code. Okay, for example here they have a white color, so meaning that is no correlation. Okay, zero is no correlation. But it's, let's say, red color here, meaning that is high negative correlation. So if, let's say, it's a blue color, maybe blue, okay, dark blue, okay, maybe is the positive correlation. So in SPM they have color coding. Color code is something you need to go through. Okay, for example here is appear here is a color, okay, blue color here, so meaning that is the height correlate, positive height correlate between the oscillation and tube size. Okay, and then is a negative correlate between the tube size and the user bias. So meaning that if, let's say, you are from the regression background, so this one is we call it VIF, is it? Okay, or with something like covariate between the variables. You can see that for each variable itself. Okay, so this one. So I go back to the activity window. You choose correlation. So you choose this one and then click. Okay, so they provide the correlation. So they also provide the scaling vector. Okay, you can see that the 3D scaling vector, and then they provide the correlation stat, which is the minimum and the maximum for each variable here. Okay, so it's more comprehensive. Okay, I go to the next one. Is the main purpose here is a model. If, let's say, you want to build the model, you need go for the model menu button. Okay, so once you choose the model, they provide the menu, a model setup dialog box. Okay, inside the menu setup, they need have the variable selection, okay, target type. They have something like you need to include before go further. You can see that this one is a red color, is it? Meaning that it's important factor you need to consider before you go further. So meaning that you need to go choose what is your target right now. So based on this case study, okay, our target is a user's bias. Okay, so you choose the user's bias if your target. So once I click the bias, now model BR the black color. Okay, meaning that now you can directly create the model. Okay, SPN assume that the others BR the predictor without you select all the predictor. It's a default setting. Okay, for example here I just choose, I don't choose the target, so you can see that the red color. Okay, so here is our target, the rest are the predictor. And then as we know, our target is user's bias is the regression, is the number, so you choose the regression. And then after that you see that here is, we call it analysis engine, meaning that is algorithm. Okay, so for this case you see that, go back this one. So all this algorithm. So we have a GPS, logistic, Mars, random forest, regression, rule learner, tree net. So for this case, I just proceed with the cut decision tree. So basically for every algorithm, they have parameter inside there. Okay, so maybe you can go for the categorical. Okay, for splitting, you want to create your own splitter, okay, or you have a constraint between the variables. Okay, you have the select classes, you can select the classes, you can have best the tree, okay, whether you using the set of standard error rules, and then you can have the let's say is a surrogate and the competitor. This one is for the missing data, okay, or outlier data, and then you have method, okay, inside the method for the splitting method, we have a Gini for the classification, but today we have go through for regression 3, we have whether least square method or least square absolute deviation. Or you can use linear combination for the splitting part. Okay, you want to split whether it's yes or no. So maybe you can using least square or you can using the least absolute deviation. Normally we proceed with the least square. Okay, or you have limitation. Okay, you have limitation or something like you want to have a parameter, you need to consider do not create determinant node smaller than 1. Okay, so you can manipulate all this one. Penalty, okay, and the lag. Okay, lag basically if let's say your data is a time series maybe 2 days selling, okay, effect to tomorrow selling. So this is it differences between that, consider that as your variable. So you can create in this lag into your data set, okay, in SPM. So no need go through one by one, so they calculate for you. So the lag. And then we have a automate here. Okay, automate meaning that after this I will explain what is automate. But the most important here is go through for the testing data set. What I say that the differences between traditional and the machine learning is a testing data set. Whether you're using the fraction, okay, fraction meaning that splitting the data 20-80, okay, 20 be your testing data set, 80 be our training data set, or you have a test data set containing to others file. Maybe this one is, we consider that the new data set be our testing data set, the old data set can be our the training data set, or you can go for the cross validation part. Okay, for this case, for this default setting, we're starting k equal to 10. So, but depends on you. Maybe you want to go for the k equal to 4. So meaning that you split the data into k group. Okay, 4 group means that k is a refer to how many grouping of your data set. Okay, or you can determine the CV, or you can spread the learned data set. But today, I just want to choose with the fraction of cases selected randomly. Okay, and then after that, I just go through for the cut decision tree. So click start here. Okay. Okay, so now you get the cut. Okay, I go back to this one. You choose the model, you need to decide your target, decide your predictor, and then you need to choose your target, whether it's regression or classification. So you go for the testing data set, and then you click start. So now you get the cut. This one is a tree. Okay, so inside the tree, this one is, we call it topology. Inside the tree, you need to go for the model statistic. So which is the same with the R squared in the regression part. So this one is we just looking for the R squared testing, whether is it okay or not. So you can checking 0.882, is it okay? So this is the best one, is it? Is above 0.7. Okay, so it's quite okay. And then the terminal node have his 16. So 16 terminal node here. Okay, and then for your information, if let's say it's for regression, they provide you 2 measurement, whether you go for proceed with the mean or you will go proceed with the median. But for this case, I just proceed with the mean. Easy to see. Okay, after you choose this one, so we have another parameter. Maybe you consider BR the best model. Okay, BR best 3. So you can looking for the relative error. So smaller error is a good model. Okay, so whether you can go for the optimal or you can go for the mean 1 standard deviation. Okay, maybe have something like differences. Okay, so if let's say I choose the optimal, so you can see that these 3 have a 16 nodes. Okay, with the R squared 0.882. But if let's say I choose the mean 1 standard deviation, you can see that now I just proceed with the 9 nodes only. And then another way to do the advantage of the card, you can go for the grow up. Okay, you want to add more nodes. Okay, you can see that. After you grow up, you can prune back to this one. Okay, you can prune back this one, or you just put it this optimal. Okay. So if let's say this one is a bigger for you, maybe you can go for the, we call it splitter, in the split. Okay, so split. You can see that this one is a predictor. Okay, tube size is oscillation, tube size, oscillation. So all this one, all the splitter is coming from predictor. Okay, maybe you can go to details. So go for the details one. What I see that said this one. Okay, just now. You can see that this one is the red color, meaning that is the terminal node. Inside the terminal node, you have the predictor. So basically, if let's say you have a 60 terminal node, meaning that you have a 60 decision rows. Whether it's a tube less than 0.69, okay, go to this side, okay, and then from there, oscillation less than this one, so you can go for this one. So your average, your predictor is 0.653. So this one is the first terminal node. So you can get all this one up to the 60 terminal node. Okay, because now you have the 60 nodes, meaning that you have a 60 decision tree. Okay, so meaning that. Okay, or maybe from the 60, okay, from the 60, which one is the best decision tree for you? Okay, so meaning that you go for the highest mean. So you see that now is the color code again, is a red color, this one is a blue light color. Okay, so it's a high red color, meaning the high mean for the user's bias. Less here is a low mean. So depends on your objective, whether it's considered that less or high. So for this case is we say that it's a high. So meaning that we have 4 terminal node with the highest user's bias. Okay, with the highest user's bias. So you go to summary, which is which one? So go to terminal node. So meaning that you have the highest one is the terminal node 1. Okay, so terminal node 1. So go back to this one, terminal node 1, right click, you choose the rows. So meaning that with the highest user's bias, meaning that from the tube size less than 0.687 and oscillation is less than 4.850. So meaning that the highest user's bias is coming from tube size. When tube size is less than or equal to, and then oscillation less than equal to. Okay, so this one is the first one. The second part is which is we want to do the causes bias. Okay, investigate what the cause bias. So meaning that is a refer for the predictor. So which the most important predictor impact to the user bias reading. So go back to this one, go to summary. Okay, you choose the very important. Okay, so you can see that now is a tube size, and then oscillation is the main causes into the user's bias. Okay, so you can see that score. But I want to stress here in the SPM, we doesn't have any type of role up to how many score we consider that the best predictor for you. Okay, it depends on you, but we provide the scoring here. Okay, so for example, is the main causes of the user's bias is tube and oscillation. Okay, but the parameter inside the tube bias, you can go back to this one. Okay, rows. So you can see that is a less than 0.637, and then more oscillation more than less than 4.85. So this one is the how we want to interpret the cut. From the cut you can get this one, but I think it's an important part or important thing. Okay, first you get the factor. After you get the factor, you know the level for each factor, which one is more important. Okay, this one is, we consider maybe if you confirm from the DOE, this one is a level for tube size, this one is a level for oscillation. So you can manipulate which one. So now you can have a 60 decision tree. Okay, but never mind. So you can go again for the summary. Okay, you can see that you are coming from the regression background. Maybe you are familiar with MSE, MAD, MAPE, okay, ICE, ICCBIC. So they provide all this one. But for this case, because we choose the splitting data set, so we're looking for all this on the test data set. Okay. So after you consider that this one is the good models, so you can go for the score, meaning that is predictor. In SPM we call it the score. Okay, score. So maybe you open the data set. Okay, maybe the same data set. Okay. So, sorry. Okay, sorry. Open. Okay, so you can manipulate this one. I just want the move. Okay, save all this one. Just proceed with the desktop. Okay. So I just proceed with the Excel. This one. So click save it. Yeah, click score. Okay. So if let's say you have a new data set, so you can do the scoring data set. So I go to desktop. Okay, my desktop. You can see that the water meter score. Okay, the water meter score. So now you see that we have a response. Okay, we have the user's bias here. We have residual. We have node. So meaning that response here is a new predictor. Okay, so new predictor. This one is the new predictor with the same variables of you already. So this one is response, meaning that is a predictor value. Okay, so this one is how SPM works. Okay, after you get the best model, you consider the best model, and then you know now the main predictor. You know now the level for predictor, parameter per predictor, and then you can go for the score data set. So score, so you can score it. Okay, you can manipulate all this one, and then you just click score. So now you can get the prediction value. Okay, so they also provide the residual, meaning that response minus the users, you can get the residual. Okay, I think this one already done. This one, okay. So the other features we call it the automate. Okay, go back to this one. Automate. Okay, this one is a good thing. Okay, features. Okay, we call it the automate. Is a powerful machine for automatically running modeling experiment. Okay, SPM offer over 18 different automated modeling option. Okay, automatically generate the collection of related model. Okay, is around 100,000 of related model looking for the best performance or best balance of performance and simplicity. Okay, so different model have different automate, or meaning that have a different tuning parameter. Okay, so meaning that if let's say you go for the cut, so this one is the automate can do for cut. This one is a random forest. You can see that the impact of different bootstrapping, discover the impact different learning and testing partition. Okay, so you can see that the discover the performing repeated cross validation. Okay, maybe of mass, you can see the easy to find the best minimum span value. Also, all this setting, you can go for the automate. Okay, but today I just going because it's not enough time. I just go with the one automate first. Okay, go back to the model setup. Okay, model setup. Sorry, sorry. Okay. So this one, I just get back to this one. All this predictor, statistic. Okay. 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 So we get this one. Go to automate. So from here, you see the type of automate. But today I just go first one is the models. Okay. Models means that I chose the automate models means that you run all the analysis engine inside the SPM, which is you want to create the card, Mars, random forest, TreeNet, GPS, and so on. So they provide to you. So you choose this one and then you click start. Because this one is something like before you get the best model, you try and error all the models. Okay. So which is they take some time because they provide all the models to you. Okay, so you can see that which one is the best model suggestion by SPM to you. So maybe I go for the R squared. So the highest R squared is the best one. So mean that is TreeNet. Okay, the suggested from the automate TreeNet. This case is TreeNet is the best. So if let's say you see that this one, so you just double click on the TreeNet. So they provide the TreeNet. So meaning that in TreeNet you have the number of tree here. Okay, number of tree 113. Okay, and then your R squared is 0.88 is a more than cut, and then go for the summary. So because you want to see the variables important here. So the same thing, variables important here is a tube oscillation, tube size and oscillation also have the highest scoring from the others one. And so meaning that cut is it starting model, maybe you want to go for the advanced highest accuracy if let's say you're using the TreeNet model. So it's something like they give it you the idea what is the best one. Okay, but this one is a depend on you. Okay, whether you want to using all the variables, maybe you want to split the variables, something like I go back to the card. Okay, I go back to the card, you see that summary. Okay, you go for the variable important and say you see that you just only want to create the card with the tube size and oscillation. You just select all and then you keep this. Okay, so this one, or you can, sorry, new, keep and go. Instead, they create for you just only with the tube size and oscillation. Okay, meaning that this one is you now you have a 22 terminal nodes. Okay, from 22 you can go for this one. Okay, go back to the summary. Okay, maybe you go for the terminal node with the highest one is terminal node 1 also. Right click, okay, rules, and can see that this one is the same result from the 16 terminal node. So this one is you can manipulate because it's a difficult, with this only one step you can get the best model. You need to try and error. Okay, so this portion already done. Okay, maybe summary for this one. Okay, powerful machine learning tools such as XCAD, random forest, TreeNet, gradient boosting, and multiple adaptive regression spline must are useful addition to any practitioner toolkit, particularly when faced with the larger data set. Okay, the approach of both sides, whether it's a Minitab statistical software and machine learning is a Salford Predictive Modeler, play a critical role in finding the actionable intelligence. Okay, it will be the collaboration and communication between two data-driven discipline, which is enable the organization to make a better decision and again a competitive edge. So that's why if let's say you my customer always ask what is difference suffered with this one. If let's say your data set is a larger, your data set have a missing data, data set is outliers, okay, and then you doesn't want to do the something like assumption, so you can go for the SPM with the card decision tree maybe or 3net or something like that one. Okay. So any question? Okay, any question? Hopefully you okay. Okay, any question? Okay, I just repeat again. First, we get before I end this one. Okay. Okay, yes, you can get this PowerPoint, but you need to drop your email and I will send to you. Okay. So you can get the terminal nodes, okay, you can get the tree, and then from the tree you can get the how many terminal node. From the terminal node, what is the important parameter inside the terminal node is a decision, and then what is the main predictor is from the variables important. So inside there, this one is the mechanism of the SPM. Okay. Okay, so okay, so if let's say you have others question, you can drop me. How to know the regression model from the output? How to know? Okay, sorry for I not get your question. Yes, you can get the slide for this webinar, but you need to drop your email. If let's say you want to see the video recording, you can subscribe our YouTube channel. Okay, Minitab Malaysia and Singapore. Okay. Okay, for this Salford Predictive Modeler, we have the uh, regression analysis engine. Okay, for information, we have regression analysis engine, but inside the output for regression using the Minitab, using the Salford Predictive Modeler, they not provide the equation to you. Okay, just you have a variables important. Uh, they not provide the equation because the main of the basic algorithm for the SPM is coming from the decision tree. If let's say you want something like equation, okay, you need go for the mass regression spline model because they have something like equation, but not straight to the point like regression. They have using the basic function for the mass regression spline. If let's say you want to have something like a regression model, but you want to use in the SPM, so you need go for the mass regression spline. But this one is something like subjective, is it? Not all the data set have the same thing, okay, same model, so you need to try and error. Okay, and they check the high accuracy, which one is the highest accuracy, and then that algorithm is the best for you. Okay. Okay, what is the use of 3D scaling vector? I'm not sure. This one is a refer for 3D scaling vector for correlation, is it? Okay, so maybe this one is the correlate. The main idea of the correlation, if let's say you're coming from the regression part, is covariant between variables A, variables B, variables C. So if let's say have more correlate, so have a highest VIV. So it's something like is you cannot get the good regression. Okay, so that's why if let's say you have highest covariate or something like that one, okay, so you can go for the decision tree. Okay, so if let's say you want this slide, so you need to drop your email. Okay, so if let's say doesn't have any question, okay, doesn't have any question, if let's say you want go further, okay, for Salford Predictive, you can visit our website www.minitab.com or www.visit.com, or you want to contact us, contact to the sales at visit.com or minitab@visits.com, or you can follow us to get some trick or some tips and trick, okay, by our media social, which is Facebook and link, the same thing, the same name, Minitab Malaysia and Singapore. And then don't forget to subscribe our YouTube channel to access back our previous webinar. Okay, and then another one is you need to fill up the form before you exit for this webinar. Okay, so thank you and stay safe.